Chapter 4, Day 2, Reading Parabolas. What information can we pull from the graph of a parabola? We've been talking about domain and range, but that's about any kind of graph. Now we're just going to specifically be talking about parabolas. And then what does that information tell us about the equation that that parabola represents? So when we're drawing parabolas, parabolas represent quadratic equations. First semester, they're all going to open either up or down. Second semester, we'll see some ones that are sideways. Those won't be functions, but they're still quadratic, still be parabolas. And before I actually start delving into them, I want to remind you what they do and don't look like. They don't look like that. I get lots of students that draw them like that. They don't look like this. It's not like a horseshoe. They look almost like a V, except not like a V either. So all of these are going to be big no's. What they do look like is almost like a V, but more rounded. But the key is they do get wider and wider and wider. They don't go straight up. That's why when we have one like this, the domain is all real numbers. Let's look at our first parabola. And what we're going to be doing, we could talk about the domain and range, that'd be fine. But we're going to actually talk about features about how this one fits in the coordinate plane that we're going to be using to graph it. If I just knew the domain and range, I couldn't really graph the parabola. But what we're going to be doing is graphing parabolas from several different forms. Sometimes when we graph the parabola, we're going to start with an axis of symmetry. This isn't really part of the parabola, but it's an imaginary line down the center of the parabola where it's a mirror image on either side. When I teach this in Algebra 1, I paint half of one in nail polish and then fold it in half along the axis of symmetry, and you see it's a mirror image. It's a reflection. So the axis of symmetry is when we have a parabola that opens up or down. When it's a function, it's always going to be an x line. It's a vertical line. So this is another chance to remember that x lines are vertical lines. So this one is going to be x equals 2. That's that x value where that parabola turns around. And the vertex is always on the parabola. The vertex of this one is 2, 1. And so the vertex in this one, it's going to be a maximum. I'm going to come back to that in a minute. But it's a maximum because this parabola, imagine somebody throwing a ball up in the air, they throw it up, and then it comes back down. That's what parabolas mimic, is that kind of motion. So the vertex is really important. We'll come back to the maximum aspect because this one opens down. That vertex, the x value is always the same value as the axis of symmetry, or vice versa. You can always see the axis of symmetry x. It's always the x value of the vertex. This one we can also see the x-intercepts. That's not always going to be the case, but this one does have x-intercepts. The x-intercepts on this one are 3, 0 and 1, 0. So of course they're x-intercepts. They're always going to have a 0 for the y value, and that's important. Sometimes we're going to graph a parabola just by starting with the x-intercepts. That's one way to graph them. And then this one we also can happen to see the y-intercept. The y-intercept in this case is 0, -4. So if we knew the equation, we could graph this sometimes using just the x and y intercepts, sometimes using axis of symmetry, finding the vertex and graphing it from there. And there's another one we'll do first, so I'll leave that one till the next video. So maximum, again, this one has a maximum because it opens down. It comes from the vertex. So the vertex on this one is 2, 1. So the maximum value, it's called a maximum because, again, picture a ball being thrown up in the air. It's thrown up. The maximum height that it reaches is 1. That's the y value of the vertex. When does that happen? It reaches that when x equals 2. So again, I'm going to draw this over here. Someone throws it up in the air, it reaches the maximum height of 1. When does it happen? When x is 2. And then it goes back down. A tidbit about me drawing these. I have a lot easier time drawing them when they're right side up. So when they're upside down, sometimes I spin the paper, or in this case the iPad around when I draw them, because I don't draw the ones that open down well. This one I could draw a little better. So this one, let's see, our axis of symmetry, this time, again, this is not part of the parabola, it's just one of the defining features of where it's sitting in the coordinate plane. The axis of symmetry is an x line, it's x equals 0. It's the y-axis, but the y-axis is the line x equals 0. And our vertex is also our y-intercept on this one. That'll happen. The vertex is the y-intercept. That y-intercept vertex is 0, -4. And the x-intercepts we can read on this one. They're equally spaced on either side of the y-axis. Remember, y-intercepts will always have 0 for the x. X-intercepts will always have 0 for the y. No matter what kind of graph we have, that's going to be the case, which is why we found it so important to talk about that so much with lines. So those are the defining features of that graph, and that's kind of a special graph we'll learn about. The maximum and minimum, this one, which does it have? Well, this one, it goes down, turns around, comes back up. Or really, let's do it the other way, because we read graphs from left to right. So it goes down, and then it comes back up. So where does it reach its minimum point? It reaches its minimum point at -4. When does it reach that minimum height? It reaches its minimum height at when x equals 0. So why do we remember that the minimum is a y value? Well, we can't talk about the minimum value of the x because it goes on forever. We've talked a lot about domain and range. The domain on these parabolas are all real numbers. So we can't talk about a minimum x value. There's no such thing. It keeps going on and on. But the y value, it definitely has a bottom on it. That would be the number that you're discussing when you talk about the range. Right? I'm not going to write it on this one, but the range would be y is greater than or equal to -4. That -4 is the minimum value. You can see I missed my little dot there a little bit, but I'm going to keep going. Our axis of symmetry on this one is x equals -5. Our vertex is about the only information we have about it. We'll learn a little bit more about it going forward, but for our purposes today, the only thing we need to know is its vertex is -5, -2, and so its x value is the value of the axis of symmetry, and then the y value is how far is it down there. All we have is the vertex. It doesn't have any x-intercepts, and we can't read the y-intercept. It'll have one eventually, but it's probably down like 20 or 30. So it's not in the picture, so we're not going to talk about it. On this one, it again opens down, so it's going to have a maximum value of the y value of the vertex. It goes up to -2 and stops, and then that happens when x equals -5. I wanted to show you one that was a little skinnier. They do get skinnier and wider. Again, they follow a lot of the same rules as the absolute value graphs. We'll see tomorrow. So my axis of symmetry on this one is x equals 7. I abbreviate this time. My vertex, again, something special about my vertex this time. My vertex is also my x-intercept. Once again, I can't see the y-intercept. It'll have one. It's just going to be way, way, way up because it's a very narrow parabola. So I don't know, maybe it's up at 100 or 1,000 or something. But it has one, we just can't see it. The domain's still going to be all real numbers. It's still getting wider and wider. It's just happening very, very slowly. It's going up more quickly than it's going over. And so we can talk about the x-intercept. Again, something special about it, it just kind of bounces off and then returns back up. It's got a minimum value because it opens up. Its minimum value is 0 when x equals 7. What information can we pull from the graph of a parabola? Just think about what different points we talked about. And what does that information tell us about the equation? Remember, whenever we see graphs, we need to be able to pick out which equation they go with just as much as we have to graph them, if not more. So it's important to know, based on me seeing a picture, what's the equation? Based on me seeing the equation, what's the picture?